Hello, students. I'm Jongtam David, your chemistry mentor. Today, we'll tackle 45 important questions from Haloalkanes, specially curated for your Neet exam 2025. And I hope this is going to be helpful for those aspirants in 2026 as well. So, with your exam on 4th of May, you have 37 days left. Make the most of it, and this series will help both 2025 and 2026 aspirants. Feel free to ask your doubts in the comments section and I'll address them in the next video. So let's dive in and strengthen our concepts. Wishing you all the best for your preparation. Let us read the first question. It says orthomethoxybenzene is treated with sodamide and then with ammonia. So the question is asking find the product that is going to be formed. So according to the question, you have orthomethoxybenzene, which is a substituent. Ortho position, you have bromine, and this is your orthomethoxybromobenzene. When this is treated with sodamide, there will be removal of this product, HBr, and bromine will go away along with hydrogen. You will form an intermediate. This intermediate is called benzyne intermediate. Okay, I'm going to write the benzene structure like this, and one more bond, triple bond. Further react with the amide from sodamide. You will form more stable product. There will be two product. One is the ortho product and another one is the meta product. Okay, like this. NH2, negative charge on the meta position. And you know which is more stable? Methoxy. And the amide comes in the meta position. Due to resonance, the negative charge is localized on the ortho position. Subsequently, you keep on adding this ammonia, and there will be removal of this amide group from this benzene ring. So now that you have the final product, the final product is called, according to the structure, if this amide group is gone by addition of this NH2, NH3 ammonia, you will form the final product. So since this uh, methoxy group is present in the meta direction with respect to this NH2, we call this meta methoxy aniline. So from the options, if you check, I think the correct answer will be D. Let us see the next question. Question number 2. Geminal dibromide is, so this is very easy. Geminal. So geminal dihalides are those in which two halogen atoms are attached on the same carbon like this. Okay, if the halogens are attached on the same carbon, we call it gem, where X can be your group 17 elements, or according to the Mendeleev's classification, it is in 7A subgroup. So find the answer from this. The halogens, that is bromine, should be attached on the same carbon. So the answer will be B, right? So you can expand the structure like this: CH3, C, Here you can write Br and here Br, then CH3. The name is called 2,2-dibromopropane. Answer is 2,2-dibromopropane. Coming to the next question, question number 3. Arrange the following compounds in order of increasing dipole moment. Toluene metadichlorobenzene, orthodichlorobenzene, para-dichlorobenzene. So in para-dichlorobenzene, the two equal dipoles are in opposite direction. So hence the molecule has zero dipole moment. Because as you know from chemical bonding, symmetrical molecules have zero dipole moment. And in ortho and meta-dichlorobenzene, the two dipole moments are at 60 degree and 120 degree apart respectively. Okay, and this according to the parallelogram law of forces. The dipole moment of ortho-dichlorobenzene is much higher than that of meta-isomer. And lastly, toluene with plus I effect or plus I group, it will possess little dipole moment. So I'm going to write the sequence, okay? The sequence of the increasing dipole moment order, such as, so this will be your para-dichlorobenzene. According to the question, it is given as 4 CH3. We have to account this based on plus I effect. Okay, this is according to the question, I think toluene, right? It is option 1. Then you have to also check the dipole moment. Next comes the meta-dichlorobenzene. And last of all, it is your ortho. Position number 2 or position number 5. Okay, with respect to this chlorine, we call it ortho. So arrange this, you will get the correct answer in option number B. It goes as 4, 1, 2, 3, right? 4, 1, 2, 3. So this is the increasing order of dipole moment. Good, let us move on to the next question. Question number 4. The compound formed on heating chlorobenzene with chloral in the presence of concentrated sulfuric acid. So you know DDT, it is polyhalogen compound and it is prepared by heating chlorobenzene and chloral with concentrated sulfuric acid. So chloral, you know the formula of chloral, CCl3 with an aldehyde group. This is your chloral. Okay, treat this with your chlorobenzene, haloarene. I can reproduce this hydrogen here. So when this reacts in the presence of what acid? According to the question, it is given sulfuric acid. So by treating this with sulfuric acid, there will be abstraction of water molecule because it is a dehydrating agent. After this, you will form the product. Okay, by removal of this water molecule, condensation take place. Chlorine here. So you can name this compound. This is your DDT, right? Or in the IUPAC nomenclature, you can count it as 111, right? Trichloro 2,2 bis, or you can say parachlorophenylethane, or in short, DDT. This is the answer. Next, let us move on to question number 5. Which among the following is most reactive towards SN2 reaction? Substitution nucleophilic reaction. As you know from theory part, it's there in your NCRT text. primary alkyl halides, they have the least steric hindrance at the alpha carbon atoms. So they are the most reactive towards SN2 reaction. So the answer for this question will be based on primary alkyl halides. Okay, you have to check the primary alkyl halides. They are the most reactive in SN2 reaction. So select, this is your methyl halide. Okay, I'm writing in MEX form. You can expand it as CH3, chlorine, bromine, anything. So this is your primary haloalkane, and these are the most reactive in nucleophilic substitution reaction bimolecular SN2. Whereas if you look at the second option, this will not be the answer. The correct answer will be option number A. Question number 6. Let us read question number 6. In the preparation of chlorobenzene from aniline, the most suitable reagent is. Okay, let us read all these options. Chlorine in the presence of ultraviolet light, chlorine in the presence of aluminum chloride, nitrous acid followed by heating with copper chloride, hydrochloric acid, and copper chloride. So which do you think is the most suitable reagent? So let us write the reaction first. You know the aniline structure is like this, right? Aniline. You have to undergo diazotization process by treating with nitrous acid. Should be in cold condition. Okay. This reaction is called diazotization because you are forming azodine, right? Benzene diazonium chloride. Now, Saint-Mayer reaction will take place if you treat with this copper chloride, and it will form chlorobenzene. This is done in the preparation part of haloarenes. So if you look carefully at the options, the correct answer for this question will be option number C. Nitrous acid followed by heating with copper chloride, Saint-Mayer reaction. Okay, Saint-Mayer reaction. Let us see the next question, question number 7. On sulfonation of haloarene, which is chlorobenzene, the product form is, you're given different types of product: metachlorobenzene sulfonic acid in option A, benzene sulfonic acid; C, orthochlorobenzene sulfonic acid; ortho and para chlorobenzene sulfonic acid. So question number 7 will be option number D, because chlorine is, this substituent is ortho para directing in nature. Question number 8. Compound A with the molecular formula C8H9Br gives a white precipitate when warmed with alcoholic silver nitrate solution. Oxidation of A gives acid B with the formula C8H6O4. And this B easily forms anhydride on heating. Identify the compound. So you are given different compounds here. Option A, B, C, D. So let us explain this with chemical reactions. So according to the question, likely this compound A must be C8H9Br. Reproduce the formula and write the structure. CH3. This is your compound A. On oxidation of this compound, what happens? Both this goes and forms a functional group. phthalic acid. Okay. It is an acid. B will be acid. When you heat this, refer to phthalimide synthesis. Now you will form phthalic anhydride, CO, with one oxygen bridge. So the formula of A, right? The question is asking not B, it is asking A. The formula of A will be, yeah, this one, right? You refer this two structure, whether they're in agreement. So the correct answer will be option D. Question number 9. The reaction of benzene disonium chloride with copper chloride. This is already done before. It is your San-May reaction. Already done before. Okay. This is your benzene disonium chloride with powdered copper chloride gives chlorobenzene. The answer is option A. Question number 10. Conan-Finkelstein reaction for the preparation of alkyl iodide is based upon the fact that, so you're given different options. This is a name reaction. Let us see the reaction. The reaction is Conan-Finkelstein reaction. It is a reaction of haloalkane. Haloalkane on treatment with sodium iodide. Don't be surprised with the name, okay? In your NCRT, it is only written Finkelstein. This Conan is just to surprise you, okay? Your simple Finkelstein reaction, halogen exchange reaction, okay? When this is treated in a solvent like acetone, recall Finkelstein reaction. Okay, this will be soluble in non-polar polar solvent like methanol. We can say acetone. Okay, acetone can be also written like this. It forms a product, another haloalkane. See, haloalkane is formed after interchanging with this iodine and X. This is interchange of halogen. The reaction is called Finkelstein reaction. And the product is sodium halide. Okay. Initially this X was from this alkyl part. Now this becomes insoluble in that particular polar, be it your methanol or acetone. Okay, acetone can be written as Me2CO or CH3 C double bond O CH3. So you have to remember this X should be only chlorine or bromine, not fluorine and iodine. So based on this, if you read the options, the correct answer will be option number B. And B is the correct answer. Sodium iodide is soluble in methanol, while sodium chloride is insoluble. Right. Next question, question number 11. Tertiary alkyl halides are practically inert to substitution by SN2 mechanism because you're given options, option A, B, C, D. So it is due to steric hindrance. Okay, because due to steric hindrance, tertiary alkyl halides do not react by SN2 mechanism. They rather react by SN1 mechanism. And SN2 mechanism is followed in the case of primary and secondary alkyl halides. So you can write down the sequence if you would like to. This is the sequence. CH3, 2, and last of all you have your tertiary. So the answer for this question will be A. Question number 12. Which one is most reactive towards SN1 reaction? So SN1 reaction involves the formation of carbocations. Order of stability of carbocations, as you know, is tertiary, secondary, and primary, right? Order of stability will be tertiary, secondary, and primary. And hence, the higher the stability of carbocation, more will be the reactivity of the alkyl halide, parent alkyl halide. Moreover, the tertiary carbocation form, it will be stabilized. If you look at the option, uh, the tertiary carbocation form, it will be from this C only. Okay, this two part. It is stabilized by the two phenyl groups present. So you have to look at this order: tertiary, secondary, primary. This is the stability of carbocation. So who is stabilizing? By the two phenyl group present. And this is the reason why the most reactive haloalkane towards SN1 reaction will be option C. Question number 13. The major product of the following reaction is, you are given a haloalkane. This haloalkane is treated with potassium hydroxide and heated. So which is the correct answer for this question? Let us see. Let us rewrite the reaction. According to the question, the hydrocarbon is C, the haloalkane is CH3, CH. What I'm doing here is I'm rewriting this haloalkane, okay? CH3, CH2, CH. Here you have one bromine, CH2, CH3. It reacts with potassium hydroxide in the presence of methanol. You have to heat this. Now after heating this, elimination reaction take place. And according to Side-Jeff rule, the product, the major product will be maximum alkylated group. Here you are obtaining two or more product, two product, okay? So you have to check the rule given by Side-Jeff's rule. So which is the correct answer? You have to check this one. The correct answer is option number D. Okay. So this is for option number D. This is for option number C, B, A. So the correct answer for this is option number D. Relate these two structure. They are same. Question number 14. Let us look at question number 14. What does it say? Only primary. Okay, here. Which of the following is an example of SN2 reaction? Okay, which of the following is an example of SN2 reaction? You have different options here. I will write here for your clarity. This is option A, B, C, D. Okay. So question is asking which of the following is an example of SN2? Remember, only primary alkyl halides, they will undergo SN2. Just find out primary alkyl halides. Okay, which is primary alkyl halides, as you know. You have to check for this. The answer for this will be option A. The rest are not primary, okay? These are all not primary alkyl halides. Question number 15. What would be the product formed when 1-bromo-3 chlorocyclobutane reacts with two equivalents of metallic sodium in ether? So this is an example of Wurtz reaction, intramolecular Wurtz reaction. Okay, Wurtz reaction, you know. Let us write down. You have to hunt for this. 1-bromo-3 chlorocyclobutane. Write down this reaction. Okay. The substrate is 1 bromo. Count from here, 1, 2, 3. 1 bromo, 3 chlorocyclobutane. In the presence of sodium, ether is the solvent. What will be formed here? This bromine will be left, minus charge, and add another sodium. Now it forms this compound. So find the answer for this question. Where do you find this? The option number D. Okay, bicyclic compound. Question number 16. You know why this compound is formed? Because bromide, this bromide is a better leaving group than chlorine. Or you can say chloride. So in this reaction, alkali metal is electron donor, which is sodium. It is electron donor, and it forms this option D. Question number 16. Chlorination of toluene in the presence of light and heat followed by treatment with aqueous sodium hydroxide gives. So let us write the reaction. You know, toluene is methyl benzene. Toluene. In the presence of light, chlorination take place and heat. Okay. All this hydrogen is going to be substituted by chlorine because you know the reaction in alkanes, they have the habit of substitution. Treat this with aqueous sodium hydroxide. Now you will form an intermediate. Heating will remove water molecule and this becomes acidic. Functional group is carboxylic acid. So the name of this acid is benzoic acid. The answer is D. Question number 17. The starting substance for the preparation of iodoform is any one of the methanol does not undergo iodoform reaction. All the others, they undergo iodoform reaction. The answer for question number 17 is C. Question number 18. The following reaction proceeds through the intermediate. You have silver salt of this acid. Bromination reaction forms haloalkane. So this is what reaction? This is Borodin-Hunziker reaction. Let us write the mechanism for this reaction. Mechanism of Hunziker reaction. Silver salt of fatty acids. We can say carboxylic acid. This is a salt. So plus minus will be there. And when bromination take place, there will be removal of this silver bromide leading to the formation of this salt. Okay. Now free radicals will be generated. PR, homolysis, thereby regenerating alkyl free radical and carbon dioxide gas. Now this free radical, alkyl free radical, will further react with this product, yellow acid, and forms haloalkane. And another free radical. So if you look at this reaction, the following reactions proceeds through the intermediate. So I think the answer is D, because all proceeds, this is free radical, alkyl free radical, bromine free radical, Borodin-Hunziker reaction. So the correct answer for question number 18, option number D. Question number 19, the major product of the following reaction is. Question number 19. Let us rewrite the reaction. Now you have this compound, methyl phenyl part here. Then hydrogen can be written like this. Methyl group reproduces hydrogen, CH3. I'm rewriting this reaction here. And bromine on this carbon. So when this sodium ethoxide dissociate, it generates ethoxide ion, which is C2H5O minus. And this group will now show minus I effect. Here will show plus I effect. This bromine will be the leaving group, and this hydrogen will donate this bond here. This ethoxide part will now take this hydrogen because this is more acidic hydrogen. Now the product, after addition of this alcohol C2H5OH and in the presence of sodium ethoxide, because this is present in the solvent, alcoholic solvent, you will get the product as such. Phenyl group here, the donation of this bond by hydrogen generates a double bond, carbon here, methyl group acids. This was acidic, and CH2, CH3. Plus I will give electrons, right? So this will be the product. The answer for this question number 19 will be option number B, because it matches this product. Question number 20, the reaction given is known as. This is theory based question. This is your Darjan's reaction. Okay. Alcohol treated with thionyl chloride gives chloroethane, sulfur dioxide, and HCl is the byproduct. Question number 21. If chloroform is left open in air in the presence of sunlight, this is also theory based question. Very simple. Gives carbonyl chloride. You can say phosgene gas. Question number 22. In the following reaction sequence, the compound 1 is. You're given different compounds here. Let us rewrite this reaction somewhere. I will write it here. CH3, C chlorine, chlorine. Here you have this formula. This is chlorine. C3H6Cl2. And this must be the formula of 1, compound 1. On treatment with potassium hydroxide, this should be aqueous, not alcoholic. Aqueous potassium hydroxide, you have unstable product. Dihydroxy compound. This is very unstable. Water is removed from this compound, leading to the formation of uh, acetone. I've told you how to write the structure of acetone before. This is acetone, or you can also expand like this. CH3, doesn't matter. CH3, same thing. From this, add the Grignard's reagent as given in the instruction. Grignard's reagent is given here. CH3, this one, MgBr, which is methyl magnesium bromide. And further hydrolysis after addition of Grignard's reagent followed by hydrolysis in acidic medium will give your alcohol. CH3. Treat this with zinc chloride according to the question. Zinc chloride and HCl. Immediate turbidity is given. So question is asking you what is the compound one. The answer for this question number 22 will be D. Question number 23. Magnesium reacts with bromoalkane base in. Although all the three compounds can be used for preparing Grignard's reagents, diethyl ether is considered as the best because it provides electron pairs to magnesium of the reagent fully for coordination. And in case of this uh, C6H5OCH3 and option number C, C6H5 and CH32, electron pair on oxygen and nitrogen are partially delocalized over the benzene and hence they are less available for coordination with magnesium. So if you would like me to draw the structure of this compound, it will be like this. RMgX coordination bond diethyl C2H5 2. So question number 23, option A is the correct answer. 24, which chloride is least reactive with the hydrolysis point of view? The halogen atom in vinyl chloride is not reactive as in the case of other alkyl halides. The non-reactivity of chlorine atom is due to resonance stabilization. And this lone pair on chlorine atom can participate in delocalization, that is resonance. And it gives two canonical structure, or you can say contributing structure. Correct answer for question number 24 will be option number D. Let us see the next question, question number 25. Butane obtained by chlorination of N-butane will be. So chlorination of N-butane can take place via free radical formation. See, if you undergo this homolysis on chlorine molecule in the presence of light, you will have two chlorine free radical. Now this will act on this substrate, that is butene. No, not butane, normal butane. This must be a butane. CH3, CH2, CH3. In the presence of light, chlorination takes place. And now it will form a racemic mixture. Racemization will take place here. Chlorine plus another racemic mixture, CH3. This is the D rotation, this will be the L form. D and L isomer. They will form 50-50 percentage racemic mixture, 50-50 each. So chloride may attack on either side and give a racemic mixture of 2-chlorobutane, which contains 50% D form and 50% L form. So the answer for this question is D, racemic mixture. Let us see the next question, question number 26. The reaction of toluene with chlorine in the presence of ferric chloride gives X, and reaction in the presence of light gives Y. So you're asked to find the formula or the compound X and Y. Rewrite this reaction. CH3, this is toluene. Chlorination in the presence of ferric chloride. Chlorine, para position. Again, toluene, chlorination in the presence of light. One is in the presence of ferric chloride, another is in the presence of sunlight, benzyl chloride. Chlorination, still sunlight. There will be substitution reaction. One hydrogen is replaced by chlorine. Further halogenation in the presence of sunlight. You will generate CCl3. Yes. So the answer for this question will be C. X is ortho and para chlorotoluene. This is a product. Question is asking the product. Y will be trichlorobenzene. Option number C. Question number 27. Which reagent cannot be used to prepare an alkyl halide from an alcohol? Very easy question. B. The answer for this question will be sodium chloride. 28. A is an optically inactive allyl chloride which on reaction with aqueous potassium hydroxide gives B, and on heating with copper at 300 degrees Celsius gives alkene C. So question asks you to find or identify A and C. A is an optically inactive allyl chloride, right? So let us build up the structure of A. This must be inactive, optically inactive allyl chloride, which on treatment with potassium hydroxide gives B. This must be a tertiary alcohol. I write here T alcohol, tertiary. And on treatment with copper at 300 degrees Celsius, this gives or you can also get, instead of this, another product can be formed, which may be Me2CH2. So answer for this question will be C. Where this Me2 represents your methyl group, okay? Either you can write Me or CH3, same thing. So if you rewrite the reaction, this is A, right? And B will be this one. This B. So answer will be option number C. Question number 29. Bromomethane on the nucleophilic attack gives product. Bromide is the free radical. It is a leaving group. The decreasing order of the rate of the above reaction with nucleophiles A to D is. You have to choose the correct answer. Will it be phenoxide, acetate, hydroxide, or methoxide? So let us see the acidic character, okay, and the basic character. Stronger the acid, weaker the conjugate base. You have learned this in equilibrium part. So let us arrange this based on acid strength. This is the highest. The pKa value for acetic acid is more than phenol, as you know. Then next is water. Water is more than alcohol. And the basic strength will follow the order. Okay. Because stronger the acid, weaker the conjugate base. The conjugate base for this acid will be acetate, phenoxide, then hydroxide, then methoxide. So compare this. A is phenoxide. Okay, where is phenoxide? This one. Acetate, B is acetate. Where is B acetate? This one. C is hydroxide given here. D is methoxide. So compare from this. You will find this correct option in. If you compare D is methoxide, right? D is methoxide. D is methoxide. C is hydroxide. A is phenoxide. B is acetate. The answer will be C. Question number 30. Which of the following will have a mesoisomer? So the compound that has two similar asymmetric carbon atoms, they will form mesoisomer. It has a plane of symmetry. So if you look carefully, the meso structure will be 2,3-dichlorobutane. Write the structure for this. CH3, chlorine, hydrogen, hydrogen, chlorine, and this is the plane of symmetry. So mesostructure will be B. Question number 31. The major product formed when 1,1,1-trichloropropane is treated with aqueous potassium hydroxide is. Let us write the reaction. Potassium hydroxide. Heat this. You will obtain this as the intermediate. Further heat this. This hydroxy will change to acidic. And here you will obtain potassium chloride as the byproduct. 3 potassium chloride. The compound will be CH2 acid. Sure. Propanoic acid. Question number 32. The major product obtained in the following reaction is. Remember, elimination reaction will be highly favored if the bulkier base is used. That is point number 1. Point number 2, higher the temperature. So hence in this reaction, bimolecular elimination reaction, this will provide your major product. So let us see which is the product. According to given criteria, let us rewrite this reaction. Here you have bromine. Look at the equation. You have to check here, okay? This is the reaction. Bromine, hydrogen. Sorry, let us rewrite this. Bromine, hydrogen. You have phenyl part. I'm rewriting the equation again. Hydrogen. So when this is treated with tertiary butyl hydroxide, potassium hydroxide, you have 1,2 elimination reaction, thereby forming this, because the tertiary butanol will be left along with bromine, and you will get this alkene 6H5 plus you have your leaving group bromine and tertiary butyl, you can say butanol. Okay, so this is your answer. Question number 32 answer will be, if you look at the answer, it will be in option number B. Compare these two, this one and this one. Let us see question number 33. Major component of Bose reagent is obtained by treating hydrogen. Okay, hydrogen hydrate with which of the following? Remember, the major component of Bose reagent is 2,4-dinitrophenylhydrazine. So if you want to draw the structure, and remember it can be obtained by reaction of 2,4-dinitrochlorobenzene and hydrogen. So Bose reagent. How to name this? 2,4-dinitrochlorobenzene. Treat this with hydrogen. Okay, one hydrogen will go with this chlorine. And condensation reaction takes place. And this will be forming 2,4. Let us see. NH2 and O2. So name of this compound is 2,4-dinitro. See how to name this? 1, 2, 3, 4. So 2,4-dinitro phenyl, name is derived from this, so hydrogen. So answer for this question number 33 is option number C. Question number 34. Bottles containing iodobenzene and C6H5CH2I lost their original labels, which are labeled A and B, for testing. A and B were separately taken in test tubes, boiled with sodium hydroxide. The end solution in each tube was made acidic with dilute nitric acid and some by silver nitrate. Substance B gave yellow PPT. Question is asking which statement is true. So rewrite all the reaction again. Um, Phenyl iodide, you have sodium hydroxide. Treat this with sodium hydroxide, you have sodium phenoxide acidified with nitric acid. And there will be no PPT. Okay, nothing is observed here. Take phenol, treat this with silver nitrate. It's given in the question. You will not observe any yellow PPT. C6H5, the second case. CH2, treat this again with sodium hydroxide. According to the question, you will get C6H5, sodium, further acidified with nitric acid. This will change to alcohol. And again, treat this with silver nitrate, you will have yellow PPT. So which is the correct answer for this? You have to find A, right? So A which we have used was C6H5. So D is the correct answer. Question number 35. Aryl fluoride may be prepared from arene disonium chloride by using The reagent for the following conversion will be option number. Let us rewrite the reaction. 36. Question number 36 will be Br. This question is defective. Doesn't have any reaction. Let us move on. Question number 37. An organic compound A on reaction with sodium in the presence of ether gives hydrocarbon, which on monochlorination gives only one chloro derivative. A is. So write the reaction. CH3, CH3, C, formula is C4H9Cl. So B 2 chloro 2 methyl propane. Treat this with sodium. You will get this is Wurtz reaction because this 2 chlorine will be taken by sodium. After that, you have to undergo monochlorination according to the question. So Wurtz reaction, you have increase in R group. So monochlorination gives you should know where you have to undergo chlorination. Okay. This is tertiary butyl chloride. Correct answer is A. Read the following and choose the correct answer. The boiling point of isomeric haloalkanes decreases with increasing and branching. Okay. For example, 2-bromo 2-methylpropane. It has the least boiling point among the 3 isomers. And boiling point of isomeric dihalogens are very nearly the same. However, the para isomers are high melting as compared to their ortho and meta isomers because it is due to symmetry of para isomers that fits inside the crystal lattice better, and as if you compare with that of the ortho and meta isomers. So 1 is correct, 2 is correct, and 4 is correct. D will be done. Question number 39. Chloroform cannot be prepared from which of the following? So you have ethanol. If you undergo chlorination, this will give ethanol, right? Oxidation of alcohol gives aldehydes, further gives acid. That is the general rule of the thumb. Now this is your aldehyde. And if you further undergo chlorination, you have chloral. We have done this before. The formula of chloral is CCl3CHO. And treat this with your calcium hydroxide, lime water. You will now generate chloroform. And the byproduct will be calcium formate. This is not useful. Now we're going to check only for this formation of chloroform. So answer for this is A. You cannot prepare from this methanol. Question number 40. Silver benzoate reacts with bromine to form. This is Borodin-Hunziker reaction. We have already done this before. We'll simplify this. D. 41. Benzene reacts with N-propyl chloride in the presence of anhydrous aluminum chloride. So alkyl iodides are often prepared by the reaction of alkyl chloride or bromide, not fluorine, not iodine. Okay, in the presence of dry acetone in sodium iodide. So which is also known as Finkelstein reaction. Sodium chloride or sodium bromide, which is formed as precipitate. Okay, it will facilitate the forward reaction according to that principle which we have done in equilibrium, Le-Chatelier's principle. And the synthesis of this alkyl fluoride is best accomplished by heating alkyl chloride or bromide in the presence of metallic fluoride, such as you have silver fluoride, mercury fluoride, cobalt fluoride, and this reaction is your Schwarz reaction. Remember Schwarz reaction, Finkelstein, Schwarz. These are all inter uh, exchange of halogens. CH3Br. I want to form fluoroalkane. Exchange with this. This is your Schwarz reaction, AgBr. So question number 41, the answer for this question is A. Is it not 41? Okay, let's see. Next question, 43. Which of the following is correct? SN2 reactions of optically active halides are accomplished by inversion of configuration. 2. SN1 reaction of optically active halides are accompanied by racemization. Carbocation formed in SN1 is sp2 hybridized. All of the above. So in case of optically active alkyl halides, haloalkanes, remember the product form, which is SN2 mechanism, has inverted configuration. And this is because the nucleophile attach itself on the side opposite to the one where halogen is present. And in case of optically active alkyl halides, SN1 reaction are accompanied by racemization. Racemic mixture is formed. Okay, in SN1 reaction, the carbocation form in the red determining step, that is RDS, or you can say slow step, it is sp2 hybridized, which is achiral in nature. So SN2 reaction of optically active alkyl by inversion, correct, okay. SN1 reaction of optically active alkyl halides accomplished by racemization, correct. Carbocation form is sp2 hybridized, correct. So all are correct. D is the answer. The reaction is described as 44. This is not given. We'll see 45. Which of the following is not used in in Friedel-Crafts reaction? The answer will be bromobenzene is used, chloroethane is used, even chlorobenzene is used. Question is saying not used in Friedel-Crafts reaction, so it will be option A. Thank you.